So, picking up the homework from yesterday, this was number 11 from the homework. Okay, so we have n equals 1,000 times 2 to the t. So if we want to find out the number of bees after 2 months, where do I plug in that 2? For the t is. For where the t is. Good. Okay. It's a positive exponent. So as we were saying, we don't have to do anything different. When it's a positive exponent, we do the math as normal. So 2 to the power of 2 is 4. So 4 times 1,000, 4,000. What's my unit? Bees. Yeah. Okay. So without having even to do this math, think logically. What do you think the number of bees is after 3 months? 8,000, because it's doubling every time. So this is for after 2 months, and then it's doubling. So then after 3 months, it's 8,000. What about 4 months? It's doubling every time. 16,000. Yeah. So logically, you can do it like this as well. You're just doubling every month. But when we get into like 10 months or 100 months, that's when using this formula will be a little easier. Okay, so what do you think t equals 0 represent then? So B, when t equals 0. So let's sub it in. N equals 1,000 times 2 to the power of 0. What is 2 to the power of 0? 1. So 1,000 times 1 is 1,000 B. And when do we have 1,000 B's? At the beginning. That's right. So t equals 0 just means at the beginning. So your initial amount. Okay. Keep that in mind. There will be questions like this in the review, in the test, where it would ask you t equals 0. What does it mean?
When will be June 1st? This is a daily question.
Yeah. So at the beginning, aka in this situation, June 1st. Yeah. No, but it's true. The question does ask you. The question gave you specific details, so we should include that. Yep. Let me just finish C and D, and then you can go grab it. Is it possible for t to be -1? What would this mean? Yeah.
Yeah, month before.
Excellent, right. So if t equals 0 is June 1st, then t equals -1 would be a month before. In this case, aka May 1st. That's right. So May 1st. Okay, and using what we know, using exponent rules that we know, 1,000 times 2 to the -1. Let's work this out. Although I know you guys know the answer right away, but we'll do this for the sake of the lesson. 2 to the power of -1, what does that equal? What's 2 to the power of -1? Remember, flip the base? 1 over 2. To the exponent 1, which is just the same thing. And so what's 1,000 times 1 over 2? You get 1,000 divided by 2. And so n equals 500 bees. Okay, and it makes sense. May 1st, you have 500 bees. June 1st, you have 1,000 bees. July 1st, you have 2,000 bees, and so forth. Okay, so this part D, it's a little tricky. When are there 125 bees? So looking at our formula, n equals 1,000 times 2 to the t. Where do I sub in that 125? is 100. Do I replace the t with 125? No, t represents time. So which letter represents number of bees? The n, right? N is the number of bees at the end. So right here, if I tell you that there is 125 bees, that's what you are substituting for. Okay, so 125 equals 1,000 times 2 to the t. Okay, so this one is we will get into solving these later on, but I'll go to the steps where I think you guys are still able to manage in grade 9. Okay, so to solve for t, this is one part, so I'm going to move this 1,000 over first. Okay, since this is 1,000 times this, what's the opposite? Divide, yeah. So 125 divided by 1,000. We do the opposite whenever we move something to the other side. We're like undoing it. 125 over 1,000. I can reduce this. When I reduce this is 1 over 8. Okay. Now 8 and 2. What's the connection between 8 and 2? Yep. 8 is 2 to the power of 3. And the 1 over part tells me what about the exponent? Negative. Excellent. So if I were to change that 8 to a base of 2, I could do 2 to the negative 3. Alright, does that make sense? 1/8 is the same as 2 to the power of negative 3. Why I did that is now my left side and right side both have a base of 2. So that means t equals negative 3. Okay. In terms of months, what month is it? 3 months prior, so the date is what do you think? March 1st. Good job. March 1st. 3 months prior. 3 months ago. Oops. So it's March 1st. Okay. So this one is tricky. When you get into grade 12, that's when you will do more of these using ln, the ln function on your calculator. So those who are excited about like doing these kind of math, you'll just have to wait a couple of years. Okay. So I thought that was worth taking up. Any other questions from this homework? Okay, good. So we are going to kind of like do a summary of what we did these few days with exponents, but I'm going to introduce using variables. Okay, so applying what we know on variables. So that's the lesson today. So I am going to finish out my... applying what we know on variables. So first, let's recap the exponent rules that we've learned so far. When we multiply two numbers with the same base, what do you do to those exponents? Add them. Good. Okay. When we divide two numbers with the same base, we subtract the exponents. When we raise an exponent to another exponent, we multiply. Okay, anything raised to the power of 0 is? And negative exponents means to flip the base. The base. Alright, not flip anything else, but the base. Okay, so let's try example 1 then. Okay, what's my base here? A, so it's the same base. I'm multiplying in between. So what do I do with the exponents? Add them. So my answer is? That's it. Oh, algebra. Okay, I'm dividing here. My base is the same. So my answer, yeah, that's it. B to the power 4. I have an exponent raised to another exponent. C to the 12th. D to the power 0. And then E over F to the exponent -2. Good job. Okay, so F over E, don't forget the square. So now then it's F squared over E squared. Okay, notice I did A, B, C, D, E, F. Okay, so far so good? Okay, now let's try some more complicated one. Just a little bit up the challenge. So this right here, what's my base?
Oh, wait.
A. Base only refers to the part that has an exponent. So my base is still A, so I can combine these. What about the 2 and the 6 then? They're just numbers that we've been working with since we were born. Okay, so 2 times 6 is simply 12. Yeah. Alright, so these numbers don't need to match. Only a base need to. Alright, so then it's 12a to the exponent 8. Yeah. Alright. 30 over 27. These are numbers again, just pure numbers. We can reduce this. What does it reduce down to? Yeah, 10 over 9. 3 goes into 30, 3 goes into 27. So this simplifies to 10 over 9. And this part right here, what about the B?
B to the power 4.
Yeah, so there's 3 ways how we can write this. We can write 10 over 9, B to the power 4, or we can write it as 10 B4 over 9. Both means the same thing. Okay, so they both mean the same thing. You can write it on the side like this, or you can write it to the numerator. Okay, this next one. Notice the bracket around the whole number right here. So my exponent would apply to that -2 as well. And also this. Okay. If I were to write this out in full, this means -2c cubed times -2c cubed times -2c cubed times -2c cubed. Okay. When I read it out like this, you can see it's -2 times -2 times -2 times -2, which gives you positive or negative? Positive, because it's a even number exponent. So positive 16. What do I do with the exponents? So c to the power of 12. Okay. Alternatively, you can do this on your calculator. -2 in bracket, raise to exponent 4. And you'll get 16 as well. Okay. Example 4. Is my answer 1? No, because there's that -5 there. That's right. So -5 times 1. D to the power 0 is 1. So -5 times 1. My answer is -5. Annie, before you know it, we're done our lesson. We have only 2 examples left. Yeah. Okay. Example 5. What should I do as my first step? Flip it. Good. Deal with the negative exponent first. Okay, so this negative exponent tells us we should flip it first. So 3f over 4e to the exponent 2. Good, positive 2. Okay, and then just like what, just like what we did up here in example 3, 3f to the power of 2. 3f to the power of 2. What's my numerator now? 9.
9F.
Square. I had to get like all 3 parts out of you guys. Alright, then my denominator?
16E squared.
Ooh, thank you. 16e squared. Good. Okay. Let's see if you guys can do this one. Example 6. Take 10 seconds. Try to write down what you think the answer would be. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up. Okay. What did somebody get? Antonia?
I got -8 times x to the power of 8
Mm-hmm.
times 1 over y, or y to the power of -1,
Good.
times z power to the power of 7.
Perfect. Okay, how many of you got this answer? Okay. If I add on another condition and say, write final answer with positive exponents only, how would your answer change? So I'll give you guys another 10 seconds to change your answer. Write final answer with positive exponents only. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, final answer. Sorry, Antonia, what did you write?
I wrote -8 to the times x to the power of 8 times in brackets 1 over.
Oh, okay. Or z to the 7.
Yes. Times in brackets 1 over y, so everything to the power of 1.
Okay, so 1 over y times this. So in other words, I can just put everything over y. Does that make sense? No? Sorry. give me 10 seconds. 10 seconds. Okay, so here, I'll add in this extra step in here. -8x 1 over y z to the 7. Okay, so this is what Antonia said. Okay, so just like when we multiply something with a fraction, we only multiply to the numerator. So that's why we have this, all this part times the 1 makes it to the numerator, and then the y would become to the denominator. Just like if we have like 2 times 1/3. Your answer is 2 over 3, right? So in this case, it's 1 over y. 1 over y, so it's 2 over y. Okay, so this is a good answer, but if the question says write it with a positive exponent, just like how your homework was yesterday, then you have to write it like this, without the negative exponents. Okay. This, yeah, you don't have to negative exponent, but it's not a final answer format because you can multiply that 1, right? So this would be your final answer right here. Okay, so that's the lesson. Minus that 8 minutes that we took taking up the homework. So my lesson was 12 minutes. Yay. Okay, so for the rest of the class, just try the back two sides. There is 24 questions. Very simple, straightforward. One answer, one line answers. Okay, so try these out. See if you can do it. We'll see if we have enough. If everybody finished by the end, we can take these up before you go. Okay.